This video is looking at the mean absolute deviation. This is a measure of variation, so it looks at the average of how far away from our mean each data value is. So to find the mean absolute deviation, we start by finding the mean. Then we're going to find how far away each of our data points is from the mean, and then we find the average of that. So let's look at this example here. So we have these 8 data points: 1, 2, 2, 2, 4, 4, and 5. So we can start by finding the mean. Remember, that's just finding the sum of all of these data values and then dividing by how many values we have, which is 8. So we would have 1 plus 2 plus 2 plus 2 plus 4 plus 4 plus 4 plus 5 divided by 8. Okay, that would be 3, 5, 7, 11, 15, 19, 24 divided by 8, which is 3. So our mean is going to be 3. And then we want to look at how far each of these data values is from 3. So starting with a 1, that's a distance of 2 from our mean. This would be 1, 1, 1, 1, 1, 1, and 2. So then if we were to find the mean of all of these values, right? So these are the new values we're using. Again, we want to look at the average of how far away each of these points is from the mean. So we will find now our mean absolute deviation, MAD, by finding this mean. So we have 2 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 2. It's going to give us 3, 4, 5, 6, 7, 8, 10. And that's all divided by 8. And 10 divided by 8 is 1.25. So our mean absolute deviation is 1.25, which means all of our data values differ from the mean by an average of 1.25. Let's look at our next example. So this one says the smartphone shows the numbers of runs allowed by a pitcher in his last 10 starts. Find the mean, the median, and the mean absolute deviation of the data. So here are our data values here. So let's start by finding the mean. That will be 4 plus 6 plus 6 plus 0 plus 8 plus 4 plus 5 plus 0 plus 2 plus 0 divided by 10. So that will be equal to 10, 16, 24, 28, 33, 35 divided by 10, which equals 3.5. So our mean is 3.5. Our median, if we write these in order from least to greatest, we've got 2 zeros. We've got, 3 zeros, followed by a 2. And we have 2 4s, a 5, 2 6s, and an 8. Let's make sure that's 10 data points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so finding our median. Since both of those values are 4, our median is 4. And then to find our mean absolute deviation, right, we're going to find the distance that each of these data points is from 3.5. So I'll make myself a little table here. I'm just going to say data and distance. So again, we have 0, 0, 0, 2, 4, 4, 5, 6, 6, and 8. Okay, so then our distance from the mean is 3.5. So this is 3.5, 3.5, 3.5. 2 would be a distance of 1.5, 0.5, 0.5, 1.5, 2.5, 2.5, and 4.5. And then we're going to find the mean of those new values that we just wrote out. So that will be our mean absolute deviation, 3.5 plus 3.5 plus 3.5 plus 1.5 plus 0.5 plus 0.5 plus 1.5 plus 2.5 plus 2.5 plus 4.5, and that will all be divided by 10. So that would give us 7, 10.5, 12, 12.5, 13, 14.5, 17, 19.5, 24. So that'll be 24 divided by 10, which is 2.4. So our mean absolute deviation is 2.4. Okay, now the next example gives us another picture and the runs he has allowed. Now, for the sake of time on this video, I'm not going to go through and calculate the mean, the median, and the mean absolute deviation again. Instead, I will just provide you with the numbers. So this one's picture A here. Now picture B also has a mean of 3.5 and a median of 4. But his mean absolute deviation is, I believe it was 1.4. So if we were to compare these two pictures, right, they're still allowing the same average number of runs per game, but we could say that picture B is more consistent because that mean absolute deviation being 1.4 means each of his data values is on average 1.4 away from his mean of 3.5. So picture B is more consistent. Picture A, maybe he has some lower numbers, some higher numbers, and so that's how we could compare these two using our mean absolute deviation.